Welcome to my video on Introduction to Vectors in Physics and Math, Part 2. In this video, I want to go over multiplication of a vector with the scalar, vector subtraction methods, and examples from physics. If you haven't seen my first video yet, it covers what is a vector, what is a scalar, and vector addition. There's a link to that video in the description. You may want to look at that before you go to this video, but it's not totally necessary. Multiplication of a vector by a scalar. Given a vector v and a scalar c, the product of c times v is defined as follows. If c is positive, cv is a vector with the same direction as v and c times the magnitude. So it just increases the magnitude. If c is equal to 0, then cv is equal to 0 times v vector, just equal to a null or 0 vector, so it just cancels it out. If c is negative, cv is a vector with the opposite direction of v and with magnitude the absolute value of c. So it just changes the direction but keeps the magnitude the same. Let's look at some examples. The first, here's our original vector v. If our scalar is 2, it just increases the length by a factor of 2 in the same direction. Now, here's our original vector again. In this case, the scalar is 1/2. So it's just 1/2 the distance or magnitude and in the same direction. Now the other example would be we have a vector, and if the constant is -2, then it just changes the direction by 2, increases the magnitude. So it's going to be twice as large as v and in the opposite direction. These are some properties of scalar multiplication of a vector. If we have a scalar times the sum of a plus b, that can be just broken up as c times a plus c times b. Now if we have two scalars, c and k, if they're summed together, times a, that's just equal to c times a plus k times a. Now if we have these two same scalars, c and k, and they're multiplied, in this case where c is k times the quantity Ka, is just equal to Ck times A. We have the case where we just use 1 times A, it's just an identity, it's equal to itself. 0 times A, it just zeroes it out, we get the null vector. And if -1 times A, it just changes the direction, doesn't change the magnitude. Now, vector subtraction is v is a non-zero vector, minus v is the vector with the same magnitude as v and the opposite direction. So then v minus w is defined as v plus minus w. So we're just going to use a little math trick right here of just adding a negative number, which is the same as subtracting v minus w. So this first method of construction, we're going to take minus w and then add to the vector v. So here is our v vector and our w vector that we're going to start with. Now we want to subtract those using this first method. So it tells us, first of all, we got to produce minus w, which is going to be this vector right here. So it's a minus, so it's the same magnitude and in the opposite direction. Now since we're going to add them together, just like we did in the first video, we take the tip to tail method. So there's our first v minus w. So that results in this vector is the difference of the two. So that's v plus minus w, which is essentially just v minus w. So that's our resultant vector from that subtraction. The second method, let v and w have a common origin and construct a third side of the triangle. Okay, so there's v and w, they have a common origin right there. Now if we subtract them, this is just going to be the difference of v minus w. So that method is simple too. Let's look at a couple of examples, the first being subtraction of a force vector. Here we have two men pushing against each other, which makes no sense, but it's an example. One's pushing a little harder with the 50 newtons to the right, and the other gentleman on the right is pushing to the left with a force of 30 newtons. So we can subtract these two forces. So 50 newtons minus 30 newtons is equal to 20 newtons, and that would be to the right. Another example, this is a velocity vector. What we have here is we have a little boat in a river, and the river is flowing at -3 meters per second, and so the boat is going in this direction, so it's going opposite the flow of the river. Now the boat's speedometer reads 5 meters per second because that's the velocity relative to the water. So it's set at 5 meters per second, but our water is going at 3 meters per second in the opposite direction. So if we add these two velocity vectors, since they're in opposite directions, essentially a subtraction. So 5 minus 3 is equal to 2 meters per second. That is going to be the speed of the boat relative to the land. So there's an example of subtraction of velocity vectors. Well, I hope you got something out of this video. If you did, give me a like, a comment, and subscribe to my channel. I want to thank you for watching.